So today we're going to talk about derivatives of log functions. So the two main new formulas we're going to work with is ddx of log base a of x is equal to 1 over x times the ln of a, and ddx of ln of x is worth 1 over x. Now we also have, ddx or ddu, or no, how do we do? Yeah, let's say ddx of log base a of u is equal to 1 over u ln of a times u prime. And then this one is much, and then this one is much better. This one is a very common one that we're going to see a lot. This is basically these are the equivalent of the chain rule for natural logs or for logarithms. So we're going to say ddx of ln of u. So what we do in this case is we do u prime, well, I'll write it out. It's 1 over u times u prime, but I always just write this as u prime over u. Okay, so this is basically our chain rules for the base derivatives. Okay, so if we're dealing with these base functions, then we can just use this. I'm just going to be honest with you guys. You guys see this one a lot, and you see this one a lot. This one comes up sometimes, but it's not as common as the other one, especially because I'm the teacher. I know which ones I use a lot more. So if we said find the derivative, and then we had, I don't know, y equals ln of 2x plus 3. Well, then y prime, we know, is just u prime over u, right? So I'm going to name this u. By the way, I think it was in my last video, I accidentally put u prime instead of, like I put a u prime here when I meant to say call that u. So I said it correctly, but if you were confused about it, go back and you'll see what mistake I made in the last video. So we have u prime over u. So this means that I'm going to write, let me switch pens. So this means that I'm going to write, what's the derivative of 2x plus 3? That would be 2, and then I'm going to rewrite 2x plus 3, and that is my derivative, and I am done. So that's all there is to it. That's how nice it can be sometimes. That's basically the chain rule for a natural log. So now let's say that we have y equals log base 3 of the sine of x, okay? So then we're gonna follow this formula right here. It says log base a of u, so this is gonna be y prime is equal to 1 over, so 1 over, and then it says u times natural log of a, so 1 over natural log, sine x times the natural log of, I'll do parentheses here, times the natural log of a, but what was a? A was 3, okay? Now we have to attach the chain rule, or the chain, which would be the derivative of sine, would be cosine x. So we end up with y prime is equal to cosine x over sine x. You know what, I'll write ln of 3, just so it looks a little cleaner, times sine of x, okay? Because technically ln of 3 is a constant. Okay, so that's how we can do these basic ones. Okay, now they're obviously going to step up in difficulty. Okay, let me give you guys a few to try. So let's say try these. So try. Let me see. We have y equals e to the x. E to the 3x. Ln of x. And then let's do one more of the nicer ones. Y equals ln of 1 minus 3x, okay? So I'd like you guys to find y prime for both of these. So pause the video, give these two a shot, and then I'll bring back a little bit more difficult problem. Okay, so hopefully you guys recognize this was a product rule, right? Because this is multiplication. So I'm going to take the derivative of e to the 3x, which I know is e to the u times u prime. So this is going to be 3e to the 3x, rewrite the ln of x, plus, now the rewrite of e to the 3x, but now what's the derivative of ln of x? It's 1 over x from our formula right here. Okay, so we have that. So now we have y prime equals, now if I want, I could factor out an e to the 3x, and that would leave me with 3 ln of x plus 1 over x, okay? And I think that's the best we can do. I mean, in your book, maybe they would ask you to make common denominators. I could do this if I wanted. This is e to the 3x, and this would become 3x ln of x plus 1 all over, oops, let me write this a little better, all over x. I think I could do that just by giving this guy a times x over times x to make them common. But I'm going to accept this answer. But you got to read the homework and see how they ask it to be stated. You got to be careful on what they say. Okay. Now this one's a nice one. I'm just going to once again do my little, this is my u, so I'm just going to do u prime over u, and that's all there is to it. So u prime would be -3, and u would be 1 minus 3x, and there's my derivative. So it can be really nice if they're good. Now, natural logs come from implicit differentiation. So that's how we built it. I didn't go through and do it in this video, but if we have time, I'll do it in another one. But in general, that's kind of the straightforward way that we do logarithmic differentiation. However, sometimes we can use a little bit of our properties of logs. So let's say that we have y equals, let me say, find the derivative of, and then I give you guys y equals the natural log of x squared over 6x plus 4, okay? So this is a tough one because this inner function, this whole thing is technically u, right? So then I'm gonna have to do u prime over u, so I'm gonna have to do a quotient rule, then I'm gonna have to divide it by x squared over 6x plus 4, then I'm gonna have to try to simplify that. So what I'm gonna do instead, is I'm gonna use properties of logarithms. I'm gonna rewrite this as ln, or the natural log of x squared, minus the natural log of 6x plus 4, right? Because that's a property of logs that says you can split the division of two logarithms, or I'm sorry, you can split the division of an argument of a logarithm into subtraction of two separate logs. But now there's another property that says, well, this is 2 ln of x minus ln of 6x plus 4. So this is what y equals, right? Now I can finally find y prime. So this would just be 2 times 1 over x, right? The derivative of the natural log of x is just 1 over x, minus, now we do u prime over u, which would be 6 over 6x plus 4. So just a little bit of brief cleanup. Now, if they ask you to clean this up, you would then have to give this a denominator of x times x. You would have to give this one a 6x plus 4. 6x plus 4. So then we would have y prime equals 12x plus 8 minus 6x all over x times 6x plus 4. Okay, so then this would be what, 18x, oh no, not 18x, sorry about that. That would be 6x plus 8 all over x times 6x plus 4. Now, I hope I didn't multiply this wrong. That would be 12x plus 8. Yeah, I was just wondering because they were so close to the same. Maybe I thought maybe I simplified wrong. I don't actually have this one worked out in my notes, so I hope this is right. If you guys see a mistake, let me know. But I'm pretty sure this is right. But again, this is technically the answer I would be fine with. Or I'm sorry, this one right here. So this is a really good answer. I'd be fine with that, but you got to be careful. Moving into chapter 4, we are going to have to do stuff like this. So, you know, try practicing it for sure. See how the homework asks you to do it, because eventually we're going to be asked to set things equal to 0 in the numerator and the denominator to find critical numbers. So we'll have to be okay with simplifying or rewriting as one fraction. Okay, so that's how you can use logarithms to help you with derivatives. Okay, wait. Yep, okay. So now let me give you guys a couple. So try these. Find the derivative. Okay, and so let's go with y equals the ln of x plus 2 times 3x minus 5, like that. Let's find the derivative of y equals the natural log of the square root of the cosine of x. Okay, that's a good one. And then let's do a nice one. Y equals natural log of x squared plus 1 to the 5th, okay? So pause the video and give these three a shot, and then when you come back, we'll go over them together. Okay, so you guys should be back from the pause. You know, hopefully it took you a few minutes, because that means you actually probably made some progress. So again, I'm not even going to take the derivative yet. I'm going to rewrite this as ln of x plus 2 plus the ln of 3x minus 5, the natural log of 3x minus 5. Now I can take the derivative, u prime over u plus u prime over u. And that would be an acceptable answer for now. Again, in chapter 4, we'll have to go a little bit further, but for now, I think that's okay. Really depends on how in depth they want you to simplify your answers in the homework. This one, I'm going to rewrite this as the cosine to the 1/2 power of x. Well, that means I can take the power and put it in front. Now, this has nothing to do with derivative. I'm using a property of logs. This is not a property of derivatives. This is a property of logs that allows me to take the power and put it in front. That sounds an awful lot like the derivative, right? Take the power, put it in front, reduce the power by 1, take the derivative of the inside, but it's not. I was just using a property of logs, you know, like if you have ln of x cubed, you're allowed to say that this is 3 ln of x. I just used that property. Now I can take the derivative. Y prime is 1/2. Now u prime would be negative sine of x over cosine of x. And then this one, they're probably going to ask you to simplify. This would be negative 1/2 tangent x. So a lot of times with trig, there is some simplification that you can do. All right, so this one is going to be 5 times the natural log of x squared plus 1. And once again, I have not taken the derivative. This is a property of logs that says I am allowed to move the power to the front. That's one of our logarithmic properties. Now I can find y prime, and this would be 5 times u prime over u, which would be 2x over x squared plus 1. And so we would get 10x over x squared plus 1. Okay. So that's that. Pretty straightforward. Let me see how much I have left. Oh, we got a few. Whoa. Quite a few left, actually. Wow. Okay, this is kind of a lot of practice problems. Okay, so now that we know how to do that, we're going to run into another problem. What if we're trying to find, what about y equals 3x plus 1 to the x, okay? What would y prime be? Now, this is a problem because in the past, the general power rule, right, says like a base of a to some, how do we say this? So like if we have 5 to the x, we can do that. If we have e to the x, we can do that, right? But what about if you have a variable to a variable, like x to the x? That's when we start running into a little bit of trouble, okay? So we're gonna have to develop a way to do that, okay? So I basically know that this variable being up here and this variable being in the base is what's causing me a problem. So I can't get rid of the x, 3x plus 1 because that's the base, but I could move that x down to the level playing field. I could move x down to here if I had a logarithm. The only problem is I don't have a logarithm, okay? Well, when you don't have something in math and you need it, sometimes you can just add it. What I'm going to do is I'm going to take the natural log of both sides. This is a property of logs that says that if a equals b, then the natural log of a is equal to the natural log of b. Or if the natural log of a equals the natural log of b, then a equals b. It's a two-way street. It can go either way you need it to. In this case, we want to have the natural log of both sides because that would still be equal. The reason I want to do this is now I have natural log of y, and I can now move the power to the front. So the thing is that I was previously unable to do that derivative. But now I have a product. Now, even though it's not a nice product, I can still do the derivative using the product rule. So what I'm going to do, now here's where you got to be careful. You're going to ddx both sides. I haven't done this in any of the other problems is because when I ddx this side, I get y prime, okay? But notice this is not plain old y anymore. So I actually have to see what's going to happen over there before I move on. So the derivative of the natural log of y is u prime over u. Well, what's the derivative of y? Y prime, because it's with respect to x. Remember, it's with respect to x, so it's not just 1. So it's y prime, and u prime over u. Well, that means y prime over y. Now we have to do the product rule. 1 times the natural log of 3x plus 1 plus x times the derivative of 3 over 3x plus 1. Okay, so now this is y. This is y prime equals ln of 3x plus 1 plus x times, you know, we can call this 3x, sorry about that, 3x over 3x plus 1. All of this times y, but what was y? Y, we said from the beginning, was worth 3x plus 1 to the x. So I can now write that, 3x plus 1 to the x. Okay, so now we have our derivative, ln of 3x plus 1 plus 3x over 3x plus 1 times 3x plus 1 to the x. So even though it was hard, I was able to find my derivative by using logarithms, okay? So sometimes, even if the problem doesn't have a logarithm, it might help to use a logarithm to bring it in, okay? So that's what we're doing with some of these harder problems, is we have to use, you could actually use logarithmic differentiation on a lot of problems we've been doing, but it just makes it harder. So you should just use the product or the general power rule or whatever. But actually logarithmic differentiation would work on a lot of problems that we've been doing. We just choose not to because there's always going to be a chain rule. There's always going to be something else. So a lot of those other rules that we have, logarithmic differentiation would actually work on them as well, but it's just more work than it's worth. Okay, so I don't want you to have like every problem in your homework and on your exam, you just decide to use logarithmic differentiation. So let's try one more. Find y prime given y equals sine x to the x. Okay, so let's try one more of these. Actually, I got a couple more, to be honest with you. So you guys give this one a shot. Pause the video and see if you can kind of copy or follow along how I did the previous problem. See if you got it good enough yet. Okay, so hopefully you guys are back. So what I did was I took the natural log of both sides. Okay, now we can move the power to the front. Again, I haven't done any derivatives yet. This is just using algebra and logarithms to help me rewrite the problem. Now I can ddx both sides. Did I forget to put brackets around that? Yeah, it doesn't technically need them, but I should do it. Because they were pure multiplication. So then this becomes y prime over y. We're kind of seeing that that happened in the last problem. And now this will be ln of sine x plus x times u prime over u, negative cosine of x over u. Now we remembered from the previous problem, we multiply the y over to the other side. So this will now become ln of sine x plus, minus. Now cosine over sine, isn't that just cotangent? So we can just do cotangent x times y, right? But we remember that y is actually cotangent of x. We remember that y was actually from the very beginning sine x over, or sine x to the x. So I'm just going to write sine x to the x right there. And then that would be our derivative. So again, a little bit more work, requires a little bit of more effort on your part, but it definitely gives us a way to deal with a power that is a variable and a base that is a variable, right? So we're worried about this kind of situation here, variable to a variable. We're not worried about this situation, and we're not worried about this situation, right? We have methods to deal with this. That's our exponential derivative, and then this is our general power rule. But this is our method to deal with a variable to a variable, okay? So that's the difference between this and what we've been doing so far, okay? All right, so let's take a look at a harder one now. Or I shouldn't say a harder one, but just a different style. So what if I told you that y was equal to x plus 1 squared, x plus 2 cubed, and x plus 3 to the 4th, okay? And I said, find y prime and simplify your answer. Now that is unfortunate that they said simplify your answer, meaning that we probably have to factor. Now, if you take the derivative of this, you're going to need to use a triple product rule, okay? And you're going to need to use a triple product rule with the chain rule and a bunch of rewriting, and it's going to be a lot of trouble, okay? Or we could use our idea of natural logs. I'm going to take the natural log of both sides. Okay, and then I'm going to ddx it. Okay, so now we have y prime over y equals, oops, got ahead of myself. Hold on, sorry about that. Erase that. I want to do some algebra first, because otherwise I just made this problem terrible. But now if I do algebra first, remember all of our properties of logs say that we can split an argument that's being multiplied into 3 separate logs. And then I can also take each of these powers and move them to the front of my logarithm. So this is going to be 2 natural log of x plus 1 plus 3 natural log of x plus 2 plus 4 natural log of x plus 3. So what I did was I split each one of these as this addition sign, right? And then I took the power and moved it to the front of the log for each one. Not taking derivatives, this is just a property of logs that allows me to move the power of an argument to the front. Now I can ddx. Okay, so now I end up with y prime over y. We're getting kind of comfortable doing that. That's going to happen all the time with this natural log of y when you take the derivative with respect to x. Now this just becomes 2 over x plus 1 plus 3 over x plus 2 plus 4 over x plus 3. And then I multiply the y over. So this will become 2 over x plus 1 plus 3 over x plus 2 plus 4 over x plus 3. And now it's going to be, let me see, we said that y from the beginning was x plus 1 squared, x plus 2 cubed, and x plus 3 to the 4th. So what this did is it pre-factored it for me. It factored out all of these powers for me. If we distributed this all back in, we would get the derivative of this if we had done it the long way, where we had not split it, but rather just did a triple product rule with a bunch of chain rules and rewrites, and then we had to factor. This is what we would end up with. So this gives it to me in simplified form. So this is really nice. Okay, now again, you didn't have to do this, so this is one of those ones where it's a choice. But I think on the exam, if I ask you one, I'm going to say use logarithmic differentiation to solve this problem or to find the derivative. And in that case, you do have to do it this way. But some of them you could do it the hard way and it would be doable, okay? Let me see here. Let's try this one. Find y prime given, geez, I can't write. So this is a rough one, right? Because, and simplify. Because this is a product rule with a chain rule, multiple chain rules, and it's a quotient. So if I ddx this right now, I'm going to be dealing with a horrible problem. So once again, I'm going to take the natural log of y of both sides, and I'm going to take the natural log of this whole thing. Okay, now I'm going to rewrite with logarithms. So this would become 1/3 natural log of 4x minus 5 plus 2 times the natural log of 3x plus 8 minus the natural log of the cosine of x, right? So all I did was I split up the argument into 3 separate logarithms. And now we're going to ddx everything, take the derivative with respect to x of both sides. So now something that was going to be really overly complicated is just going to be y prime over y. This will be 4 over 3 times 4x minus 5, right? I'm just putting the 1/3 in the denominator, plus, now this will be 2 times the derivative of 3x plus 8, which is 3. So this would be 6 over 3x plus 8, minus the derivative of cosine is negative sine over cosine x, okay? Now we multiply by y over to the other side, right? I got to put a times y right here. And then I put a times y right here. So now let's do our little bit of cleanup. So this will be 4 over 3 times 4x minus 5 plus 6 over 3x plus 8 plus tangent of x times, now let's see here. We said that y was all of this nastiness, 4x minus 5, so the 1/3 times 3x plus 8 squared all over cosine of x. Okay, and that should be our derivative. All right, so that's a nice one. A little note. With logarithmic functions, absolute values don't matter when you take the derivative, because the log already has to be positive anyway, so there's no point. It wouldn't be, you couldn't even do the problem. Logs are only allowed to have a domain of positive numbers inside anyway. Take the derivative. So this makes it kind of nice. One of the few times absolute values don't cause a lot of trouble is with natural logs. So if you took the derivative of the, or if you wanted to find the derivative of the natural log of the absolute value of f of x, you would get y prime is equal to 1 over f of x times f prime of x, which is equivalent for me saying, right, this is my u, so I would say u prime over u. So this would be, you know, I should write it the way I normally do it. This would just be f prime of x over f of x, u prime over u, okay? So no big deal, okay? And the absolute value didn't come into play at all. Because once again, in logarithms, it's almost redundant because they're automatically, the domain prevents it from being negative inside there or 0. Okay, so let's see here. Let me have you guys try a few more, and then I think we're gonna call it a day. So let's try, try and find, let's say we have y equals x to the square root of x. And then this one looks kind of terrible. Do I want to do this one? This one looks pretty bad. Hold on, let me see. Let's do this one instead. Let's try y equals x squared plus 4. 5x minus 2. That other one just, I'm running out of steam and that one would take a lot longer. Okay, so we have x squared plus 4 and 5x minus 2. So let's pause the video and you guys give, these will be our last 2 problems of the day. Let's see if you've kind of figured out how to do these problems now. Geez, I might even have another one I might want to do. But anyway, go ahead and do this one. And let me see what you got when you come back. All right, so you guys should have had y equals, I'm sorry, natural log of y equals the square root of x times the natural log of x. So I skipped a step because I know I'm going to take the natural log and then move the square root of x to the front. So I now have that. And now this will become ln of y is equal x to the 1/2 times the ln of x. I always like to rewrite radicals as exponents. Now I'm going to ddx both sides once again. And this will become y prime over y. And now this will become 1/2 x to the negative 1/2 ln of x plus x to the 1/2 times 1 over x. Okay, now there's definitely some cleanup we can do here. I'm going to multiply y prime or y over to the other side. So this will become the natural log of x over 2 square roots of x. And this will become 1 over the square root of x, because this is x to the 1/2 times x to the negative 1, which is actually x to the negative 1/2, which is actually 1 over the square root of x. So that's where I got this guy from right here. And then all of this is times y, but y was x to the square root of x, right? So I think that'll be your answer, but I have seen when you start getting into these, they start wanting it to be cleaned up a little bit better. So this would be plus 2 all over 2 square roots of x times x to the square root of x. I've seen that happen before where they clean up this little inside. So this would be an answer, but the other one is also correct as well. Okay. Oh, it looks like we need more room. Oh no, let me just erase this real quick. Okay, so hopefully now you guys are kind of getting the flow of this. So I'm going to jump ahead on this one. Ln of y times 5x minus 2 times the ln of x squared plus 4. So then this is going to become ddx, and then this will become y prime over y. Once again, very common. This will become a product rule, which will be 5 times the natural log of x squared plus 4 plus rewrite 5x minus 2 ln of x squared plus 4. Oops, oh, no, sorry, my mind got sidetracked. This would be 2x over x squared plus 4. I had forgot to do, this is my u, so this is my u prime over u, right? Okay, so let's see, y prime equals 5 natural log of x squared plus 4 plus 2x times 5x minus 2 all over x squared plus 4. All of this times y, but we know y is x squared plus 4 to the 5x minus 2. And that would be our derivative. Okay, so that's kind of a little bit longer one also. But yeah, I think that'll get you guys started on logarithmic differentiation. Depending on the book, so in the book, if you're using the Briggs book, which I think for this fall class you guys are, you guys, they don't count, it's called, the class I normally teach from is called Early Transcendentals. The book that I'm teaching from right now doesn't have early transcendentals. They don't cover it till chapter 7. So I'm incorporating all of the logs and exponential functions and trig, all that stuff in the beginning of the semester. So you'll start seeing homework problems that say chapter 7. But that just means that I'm just going at the normal pace. So you should be able to do all of them learning. It's just the book goes out of order from what I'm used to. So just, complete the homework and don't worry that it says some of the homework's from chapter 7. That's just because they held off on putting logarithms and exponentials at a different school I teach. So this should definitely get you guys started. Let me know if you need any help and I'll see you in class.